gave me an opportunity to speak in front of you. I am very much thankful to Honorable Principal S. Deshpande and Professor Bankar sir. So my today's session is on how to improve the productivity of industries by deploying the concept of vibration-based prognosis. Actually, the productivity of an industry is highly dependent on four terms. The first one is the machineries, which are skilled working persons who are motivated and who are enthusiastic. Because if they are not enthusiastic, your productivity will not be increased or increased. And second one is the facility which they are providing, the higher management which are providing to the industry persons and the industry maintenance department. And fourth one is the education which we have in our management as well as in our workers. These are the 4 points where the industry productivity is highly dependent. So, next, the 4 cornerstones. Well-maintained machinery, skilled and motivated workers, optimized and adequate resources, which are the cornerstone for the aggrandizement of industrial productivity. Next. So we have to make improvement in these areas. So I will focus on particularly on machine productivity. Means if we keep our machine healthy, certainly the productivity of industry will be healthy and will be increased. So there are 3 plans where we must focus on. That is predictive maintenance, preventive maintenance and condition-based maintenance. So I will focusing on 2 parameters, that is the predictive maintenance and preventive maintenance. Because condition-based maintenance, it is the, हम जिसको बोलेंगे जुगाड़ बोलेंगे. So we will focus on these 2 issues. Next one. So if one concentrate on further classifications where predictive maintenance would be applicable, then there are 2 areas where one may focus on. That is the power transmission devices and various process units of specific kind. Power transmission devices means what? We will see in the next slide. Power transmission devices can be further classified into 5 categories. One is the shafts, coupling, belt, drive, chain drive and gearboxes. And if we focus on the particular commodity wise, then crushers, grinders, mixers and cutters are the main areas where one can focus on to improve the productivity. It is possible to execute the research to improve the industrial processes of any one of the above stated topic. So one has to choose the sub area where he can focus. For executing a research or improvement in industrial processes, the first thing which one has to have, and that is the enthusiasm. If a person is not enthusiastic, he cannot do anything. He cannot do research even. We have to cultivate the technique for showing courage to take challenges. जैसे हम इंडस्ट्री में जाते हैं, हमको इंडस्ट्रियल असाइनमेंट लेने में थोड़ा हिचकिचाहट होती है. What is the reason behind that? A fear, a small fear. Shall I handle it or not? Or there would be a problem if I handle this situation. अगर हम begin नहीं करेंगे, हम शुरुआत नहीं करेंगे, we will not get a solution. And for that, cultivate a technique. There is nothing impossible if you do hard work. Hard work is the second one which is required. If you are not hard worker, then nothing can be possible. Cultivate the school of thought that there is nothing like intelligence. However, what is required become intimately conversant with your area of research or area of interest. Means there is nothing like intelligence. हम बोलते हैं ये बहुत इंटेलिजेंट है, he is very intelligent, ये भी बड़ा इंटेलिजेंट. No, how much you are conversant with the topic, how much you practice, how much time you have devoted for your practicing the problem. That is the intelligence. Because God has given a same equal amount of brains to every individual. Newton was not a great scientist. He was not a great scientist. He became a great scientist after inventing something. He was an ordinary student when he was in the school. If I take an example of Faraday's, he was the assistant of one of the chief scientists of Royal Society. He was just a second class student. He passed only second class. Then he joined as assistant. He developed that magnetic field. He even cannot describe how magnetic field developed, because at every year he showcasing the research to the society law on him, and that's why Maxwell run and developed the equation of Faraday's law. After that, the society accepted that law and they assured that he is a scientist. So, if a person is to extent of 90% intelligent, 90% hard work, but having only 10% enthusiastic, your research cannot be accomplished in a great manner. Once you have decided the broad area and narrow focus area, so then next step is to perform exact to literature. So keeping in all mind which the point we discussed here, so research work related the vibrations and the field, which I with my student executed through this canvas. I will focus in on that. Now, a very fantastic topic, because when word vibration comes, we actually restricted ourselves. It would be more difficult, or there would be difficulty in solving the derivations and to understand this vibration. When I was a student in final year of BE, Professor Bean taught me. He was the ex-scientist of DRDO and he worked with APJ Abdul Kalam. He said that vibration is very fantastic, but I afraid that time. But I eventually had taken this subject and my interest got a real shape, and it's very fantastic topic, vibration. So next. So if I focus on a very specific unit, that is a motor, a pump. This motor and pump is coupled with a coupling. So coupling is a power transmitting element because it transmits the power. Power means what? Is a product of torque into the angular velocity omega. Right. So torque multiplied by omega is a power. If I take a 1 power 746 watts, that is Newton meter per second. If I think about how much capacity the electric train engine possesses, so it would be around 4 to 5,000 HP. 1 horsepower means 1 घोड़े की ताकत यानी 1 horsepower. If my coupling is sustaining that much amount of load, 2 घोड़े की ताकत means 2 horsepower. If my coupling is handling that type of power, means that type of force, then certainly vibration will be induced. What do you mean by vibration? Vibration is nothing but to and fro motion of any body with respect to the mean position, upper side and lower side. It continuously vibrates in a cyclic manner, then it is known as vibrations. So we are dealing with that. So in industry, when I visited the industry, I found that they are confronted with various problems like misalignment of the couplings. We saw because misalignment is at the top priority and second one is the imbalance. Due to that, the maintenance time has increased, because if we persist the misalignment, what would happen? There would be a catastrophic failure in the machinery, and as a maintenance person, it is our duty that we have to avoid such condition in future so that our machine will run efficiently and our production will not be hampered. Right. So production, it depends on productivity. Right. So when just say next. So it is said that the couplers coupling. There are so many types of coupling which are available in the market. We just know the star coupling, then the rigid coupling and flexible coupling, only we know that. But there are so many categories of the coupling indeed present in the market. So how we diagnose the machinery that our machinery is healthy? You can diagnose by 3 to 4 technological aspect by which you can recognize. One is the vibration-based condition monitoring. By seeing the frequency of the vibration, you can diagnose, yes, my machine component is in problem. If there is a certain change in the viscosity of the lubricant which is used by the machinery, you can predict how much wear is there by only inspecting your lubricant. Second one is the NDT, non-destructive testing. These are the testing मैंने किया है. अभी मैंने हमारे इसमें लेबोरेटरी डेवलप की और उसमें बहुत सी कंसल्टेंसी. So NDT plays an important role how to detect crack आ गई क्या, उसमें porous material आ गया, resonance आ गया. You can see that vibrations will create a we will now this is the very important diagram. Actually, in this diagram, these are the two rotors. This rotor and second rotor. If I take this rotor is the motor rotor, that is the stator unit of the rotor unit of the motor. This is the rotor of the process unit. These two motor shafts have been coupled with this coupling. This is the rigid. Now, how to take vibrations? Before taking the vibration data, I will explain you what is the role of vibration-based condition monitoring. Actually, if I am suffering from a package, so what I will do? I will go to doctor. Doctor will put a stethoscope on my back, on my heart, and will diagnose the signals, whether there is abnormality in the signals or not. If he cognizes that there is abnormality, so he will go for ECG. Package एकदम ECG पे डाल दिया. Then, on the basis of regular pattern of the ECG, he will predict, no, you don't have any problem. अगर उसमें irregular pattern आ गया, abnormality दिखी, तो he will say that yes, you have to do endoscopy or angioplasty. अगर पेट से लेकर endoscopy करो और अगर हार्ट से लेकर angioplasty. Right. So, what doctor does? Doctor does is a health monitoring. He is a human. But in our industry domain, we are playing the role of machine. Machine can speak, but it speaks in its own language, and that language is embedded form, and that is vibration. It's speaking, but we can't understand. We have to translate its language to our readable form. And that's why one instrument which is known as FFT, fast Fourier transform, is generally used in industry. And one is accelerometer. जैसे स्टेडिस्कोप क्या हो गया, सेंसर हो गया, उसी के तरह इसमें accelerometer sensor that senses the vibrations and it transfers into representable form, which is known as vibration spectrum. It is produced by the spectrum analyzer, which is known as fast Fourier transform. Second, हमारा जो सेंस किया जाता है ह्यूमन डॉक्टर में, हम कहाँ रखते हैं, हार्ट पे, कभी पे स्टेथोस्कोप. So in machine, which is the heart? Bearing. Bearing is the heart because all these static and dynamic forces develop in the machine that has been transferred to the bearing, and that bearing becomes the sensor point. What do you mean by bearing? Bearing is a mechanical device which bears the load. कोई भी bear कर रहा हो, develop that bearing. 8000 BC ago, Egyptian had made this bearing, the concept of bearing. After that, the Professor Leonardo da Vinci had proposed the concept of bearing and friction. How the bearing? Actually, for the construction of pyramid, they used to make inclination of sand, and over the sand they put one wooden log, and between two plates of wooden log they place circular wooden logs, and After that, they put a stone and then they pull there. So here two phenomena comes into focus. One is the sliding friction and one is the rolling friction. And the total weight of the stone was beared by the wooden plate. And ground reactions comes together. That down reaction is the reaction. What is the difference between load and force? This is the vulnerable question which actually instigates you to think over that. Load means what and force is what? Identically they are similar, but why they are different? लोड यानी क्या होता है, फोर्स यानी क्या होता है? इन पर मैं कैंची लेता हूँ, कैंची में आपको रखती हूँ, यहाँ पे दिया मैंने, यहाँ पे फोर्स दिया, तो ये अखरोट इसके ब्लेड पे देने वाली जो रिएक्शन है, that is a load. Load is the force, but it is opposite to the reaction, and always the reaction is considered to be load. आप बैठे हैं, force weight force जा रहा है according to Newton's law. नीचे से ground reactions आ रही, these reactions are the basically the load, and that's why bearing use the load to the applied dynamic and static load, and that is why it is known as bearing, right? Yes. So here from three particular directions we have to sense the vibrations. One is the axial, horizontal, and vertical. Here you can see that there are three types of sensors which are used in vibration-based condition monitoring program. One is the displacement, then velocity and accelerometer. These are the three prominently sensors which are used. If your velocity, if your speed of machinery is less, displacement probes is used. Moderate speed, you have to use the velocity, and above the 2000 rpm or 1500 rpm, you have to use the accelerometer as a sensor. Yes. Now, vibrations, this is the time domain. This is the time domain. What do you mean by frequency? Frequency is cycles per unit time. हम बोलते हैं ना, रेडियो का प्रसारण आ रहा 50 हर्ट्ज, 60 हर्ट्ज पे। फ्रीक्वेंसी इज व्हाट? वो थ्री डायमेंशन। टाइम डोमेन में क्या आ रही है? वेव्स आ रही है। और उसको कॉम्प्रेस करके जब हम इधर से देखते हैं तो उसको फ्रीक्वेंसी डोमेन में देखा जाता है। मीन्स फॉर एवरी टाइम सिग्नल of the vibration, there is a particular frequency at which it comes. From this concept, it is made clear that every component possesses natural frequency. When one of the natural frequency exactly match with the forcing frequency, the condition becomes resonance frequency. Right? So every component possesses its forcing frequency. अगर उस फोर्सिंग फ्रीक्वेंसी में पीक दिखा, तो यहाँ देखिए ये पर्टिकुलर फ्रीक्वेंसी पे आ रहा है टाइम डोमेन, इसको कॉम्प्रेस करके एक्स आरएमएस लिया है और एम्पलीट्यूड इधर से देख रहे हैं, ये हो गया फ्रीक्वेंसी डोमेन। इधर से टाइम, एवरी फ्रीक्वेंसी पॉसेस इट्स ओन टाइम सिग्नल, और यहाँ से देखेंगे एम्पलीट्यूड। हर एक कंपोनेंट का फ्रीक्वेंसी अलग। जैसे इफ आई टेक a coupling, it has a three frequency or n number of frequency, prominently three frequency, 1x, 2x, 3x. 1x means 1 time RPM, 2x means 2 times RPM, 3x means 3 times RPM. If इस frequency पे 1x means what? अगर मेरा टर्बाइन का शाफ्ट 3000 RPM पे घूमता है, इसका मतलब मेरा 50 हर्ट्ज है। सर आपने कैसे लिखा? 3000 RPM डिवाइडेड बाय मैं 60 करूँगा, कितना है? Frequency means 1 cycle per second is equals to 1 hertz. So 50 hertz. उसको डिवाइड बाय 60 कर दो। अगर मेरा 1x यानी 50 hertz, 2x यानी 50 मल्टीप्लाइड बाय 2 कितना है? 50 मल्टीप्लाइड बाय 3 कितना है? 300. यहाँ याच्याबद्दल का abnormal peaks दिसत आहे. It means that there is a strong indication that your system possesses misalignment. Oh, it is not visible. However, I will explain. This is the offset misalignment. There are two conditions or three conditions respect to misalignment. This is the parallel or offset misalignment. This is the angular, and this is the combination. Shaft जर का असा असला तर काय म्हणू आपण? Parallel. असा असला And so आणि एक असतो असा, such as centrifugal chillers and dryers, they are inbuilt with the motor because on motor shaft they are the impellers and chiller impeller is there, so there would be not be any chance to have the misalignment. Next. So there is another reason why we are forced into this situation, because every fluid pump has its own capacity, has its own dynamics, has its own pressure. That's why we cannot manufacture at one unit. So we have to make another pump capacity and another motors. Next. Right. This is the spectrum of 150 HP motor coupled to a boiler draft. You can see this is the running speed, that is 1x, 2x, 3x, 4x, 5x, 6x, all x if you multiply of that, and if there is an abnormal increase of the amplitude, then you can see that there are a series of harmonics, and that's why there would be a chance of misalignment in the coupling. Next. Next. Coupled with each other, what would happen? They are in cyclic motion. Let us consider the center line of one shaft does not match with the center line of another shaft. What would happen? And if we couple it, what would happen? The entire housing sets into cyclic motion. One shaft will pull another shaft to come in line with it, and another shaft will pull another shaft to come in line with it. If it is purely balanced or purely aligned machineries or system, then what will happen? A pure sine wave of the time at that particular frequency will be generated. But ये रस्सी किसी में रस्सा कसी में हम tug of war देते हैं, tug of war, एक इधर खींचा एक इधर खींचा. What will happen? So that ये करने से क्या होगा कि जो bearing है उस पे additional लोड है. These two shafts falls under the phenomenon of tug of war. That's why additional load will be created on sealing, on bearings, and the full exertion of sine wave will be distorted at the extreme point of the sine wave. Next. And hence, this full exertion of sine wave will be distorted by this, and this is the modified sine wave will be generated. And that's why many a times at particular frequency we could not get a increased amplitude, and sometimes we will get some confusion to interpret the spectrum domain of vibration. Next. These are the series harmonics of the vibration spectrum of a 30 Hertz, that is 1800 RPM machinery. Next. Now, when these two shafts couple together, what would happen? By this coupling, what would happen if the misaligned shaft are coupled? They are actually one likhा है ऊपर जाइए. Two shafts roll around each other, both shafts rocking angular motion building cases. Machine vibrates up and down vertically, back and forth horizontally, up and down vertically. आप कभी लगा के देखिए मशीन नाचना चालू करती है. That is dancing. So it will back and forth horizontally, up and down vertically, and in and out axially. And that's why we have taken the vibration readings in three dimensions: vertical, horizontal, and axial. Right? So if we found 180 degree out in and out, if we take readings from the two bearings from one side of pump and one side of motor, और हमको 180 डिग्री का फेज दिखाई देता है दोनों केस में, तो हम स्ट्रांगली बता सकते हैं कि वहां मिसल है. राइट. नेक्स्ट. This is a very fundamental statement which has been given That is, you cannot detect the severity of misalignment using vibration analysis. In other words, there is no relationship between amount of misalignment and the level of increase of vibration. It means that अगर मेरा misalignment, my general perception is that amplitude भी 1 mm का रहेगा या 1 मीटर पर 1 mm पर सेकंड रहेगा. मैंने अगर 2 mm किया तो वहाँ 2 mm पर सेकंड होना चाहिए. But no, your increase misalignment magnitude does not increase your level of vibration. There is no linear characteristic. It is a non-linear, highly complex phenomenon. Next. Now, intentionally what happened? We had made, means the author had made one test in which this is the top unit and this is the motor unit. And here, previous. Two pieces of rolling machinery coupled, misaligned by 10 mils per inch. What do you mean by mil? Mil is the unit of vibration. If I read the spectrum in displacement domain, then it is mils. If I read in velocity domain, mils per second. If I read in acceleration domain, mils per second square. 1 mils means 1 by 24 inch. इतना होता है. तो 10 mils per inch, फिर हमने डबल किया उसको, स्टार्टेड बैक किया, पहले 10 मिल रखा, वाइब्रेशन गिना, फिर उसको 20 मिल किया, वाइब्रेशन गिना. तो हमारा जनरल असम्पशन ये था कि there would be linear increase of vibration. But what we found is, yes, we found these type of graphs. Sometimes they increase, sometimes they decrease. Sometimes they increase, sometimes they decrease. So why such type of complexity and non-linearity available in this dynamic system of coupling vibration? So we will discuss. There are certain phenomena which are responsible to reduce vibration at one time and increase the vibration at another. So there are fundamental two types of forces. Next one. Fundamental forces, static forces and dynamic forces. Static forces is gravitation force, V-belt and chain tension, shaft misalignment and some type of hydraulic and aerodynamic loads, which are static one. Dynamic is what? If I drive a bike, my mass is there, my linear mass moving. Change of rate of displacement with respect to time is a velocity. Change of rate of displacement, velocity with respect to time is acceleration. Change of rate of acceleration with respect to time is a jerk. Change of rate of jerk with respect to time is a jolt. Change of rate of jolt with respect to time is a crackle. Change of rate of this with respect to time, crackle is known as pop. So type of action has been taken place. Dynamics means what? When I consider the static forces along with the dynamic forces, if I consider the inertial force, that is mass into acceleration, if I consider that force in my analysis, then it is known as dynamic equation. If I consider without the mass into acceleration force, then it is a static equation. Simple static equation or kinematic equation. Understand? तो डायनामिक फोर्सेस में आता है आउट ऑफ बैलेंस कंडीशन, इसेंट्रिक रोटर क्या इसका प्लेस चेंज होता है. व्हेन प्लेस चेंज द फोर्सेस विल चेंज. ऑफ कोर्स अनबैलेंस का फोर्स चेंज होता है विद रिस्पेक्ट टू रोटर. नेक्स्ट देन डैमेज एंटी फ्रिक्शन बेयरिंग, इंटरमीडिएट पीरियड का गियर टूथ कांटेक्ट, पंप और कंप्रेसर, इंक्लिनेटर, ब्रेक, पासिंग बाय स्टेशनरी ऑब्जेक्ट एंड इलेक्ट्रोमैग्नेटिक फोर्सेस आप बता रहे हैं. Now, it is general presumption that every coupling will show a same spectrum for a given time. But friends, it is a misnomer thing. Every coupling possesses different spectrum of identity. And there are n number of couplings are there. I am showing here the vibration spectrum for principal disc type. You can see these are the pattern. Motor driven स्टेटर, मोटर ड्रिवन जनरेटर, सभी के अलग अलग है. आपका यूनिट भी चेंज हुआ तो वही कपलिंग के स्पेक्ट्रम भी अलग है. देखिए यहाँ पे थोड़े इससे दिख रहे हैं. 2x and 4x, I will cognize the amplitude. Here only on 1x. Such type of tap. Now this is the vibration spectrum of gear coupling. Altogether different. Then observe vibration on jaw type coupling. Jaw type हम coupling हम use करते हैं. ये है metal, pattern on grid type coupling और ये है pattern on tire coupling. सबके vibration की pattern अलग है. हमारा एक presumption था कि सबके एक रहेंगे. Altogether different because the dynamic forces involved in particular system is different than others. And these are the dominant to reduce the vibration at one point and increase the vibration at another. Now, one of the spatial techniques which are used in industry is the infrared thermograph. Your vibration is not sufficiently show you the misalignment condition of the machinery, but infragraph thermography is another one which can predict your bearing or wearing maintenance or well maintained. हमने क्या किया कि the author, the test was conducted by coupling a 10 HP motor of 70 to 100 watt electric motor. So flexible coupling was installed. Next one. These are the and these are the misalignment. If you increase the misalignment, there will be the increase of temperature. Yes. You can see the patterns are different. The discussion, I am very much thankful to Professor Prognosis, who has developed the concept of misalignment, and the case study which I actually had shown you, it was solely the work of Prognosis, handbook of machinery misalignment. Professor Prognosis, he actually done this case study. My intention was to show this case study is to familiarization of misalignment and vibrations, and my work which I executed with my student is an approach to understand the dynamics of two jaw. In the previous one, it is stated that we don't know there is a relationship between the amount of misalignment and the vibration amplitude. Here we executed the work. So I am very much thankful to Prognosis, who has executed a very fundamental research in coupling dynamics and coupling design. Now, we had taken a case study. We actually indigenously developed these three rotors and this coupling. Right. So we have developed an experimental setup. My next one. Now we have to go fast because it's very. We actually evolved the dynamics of these two jaw elastomeric coupling. How the load torque and driving torque, in between that our coupling becomes a node member, and how they tackle these two torque and what type of forces they actually faces. Here it is given in brief. Now if I take a lecture on these dynamics, it will require 1.5 hours. So I will skip that, only I will show you the results next one. Next one. These are the internal forces which are emerging in elastomeric material and on jaws. This is the dynamics actually. Next. This is the load torque which is generated by the dynamic forces. What do you mean by load torque? How will you design the machine? How will you design the machine? हमको machine design करना है. हम क्या करें? हमको अगर machine design करना है, तो we will first ascertain the load torque coming on the machine. right? So total torque is equals to TL plus I d omega upon dt plus TR. TR means the load torque, I d omega dt means equivalent load considering on the prime mover. Total equivalent load or equivalent inertia of the system referred to the motor shaft or prime mover multiplied by the angular acceleration plus TR means resistance torque offered in the bearing material or bearing elements. If I consider this total torque, then I will calculate the total load torque. Then that total load torque and the speed at which you want to drive your machine, that multiply will give you the design power. This is the fundamental basic theory of design. Right? Here, my student have evolved the concept how the forces actually increases. The load torque gives the forces on the coupling and these forces gives the torque, increased torque. So you can see this is the increased torque. Now ये जो torque निकला इससे हमको निकालना पड़ेगा T mean. वो T mean निकाल के हम बता सकते हैं कि पहले जो था विदाउट मिसअलाइनमेंट और विथ मिसअलाइनमेंट कितना टॉर्क है और उस टॉर्क से कितना वाइब्रेशन बढ़ेगा नेक्स्ट दिस इज द वाइब्रेशन रिस्पॉन्स ऑफ द बेयरिंग कैप दिस इज द एंगल ऑफ रोटेशन this is the bearing reaction increase due to the increased misalignment of the two jaw elastomeric coupling, and we have considered this bearing cap as a single mass, single stiffness and single damper unit, and excitation force is this which is coming on the bearing, and we had this type of vibration of the bearing cap. Means increase load will give the fundamental vibration of the bearing. अब मैंने बोला था बेरिंग क्या है सेंसिंग an approach to formulate the prognosis model here. Next one. Now we have developed this experimental setup. This is the motor, these are the two bearings, these are the two rotors, and this is the rotor. These are the two accelerometers in horizontal and in vertical direction. From this, we had measured the vibration amplitude at different misaligned positions. For this, next one, here we construct a model. The model is the prognosis model, so we have developed identification of variable. These are the processes to make the equation between the amount of misalignment and the response, that is the vibration amplitude. Next. There are the independent variable and dependent variable, which is the integral part of this phenomenon, and one is the instantaneous variable. Next. These are the least dependent variable, that is the vibration amplitude, and there are so many types of independent variables: speed, mean bearing, positions, equivalent distance, load torque. So many fundamental independent variables which are responsible to induce this vibration we have considered. We have reduced total parameters into 4 items, that is pi 1, pi 2, pi 3 and pi 4. This is the dynamic term, this is the equivalent term of this system, this is the stiffness term of this system, and this is the equivalent length of this system. Next. We have done the test planning, test envelope, test point and test sequence. For every experiment, you must have this test envelope means at what point you have to take maximum data and at what point you have to take minimum data. This is the test envelope. Then the range over which the independent variables are valid during the experimentation is called test envelope. On the next one, these are the test points. So during the experimentation at particular point, you set your experimental setup. That point is known as test point. Right? जैसे मैं 10 RPM पे deliver reading, test point हो गया 10 RPM. If I take 20 RPM, test 20 RPM is the next test. Test sequence is the irreversible experiment or reversible. Irreversible means अगर आप move forward हो गए फिर पीछे नहीं. और reversible means you can come back. You can arrive at previous position of experimental points. next, next. So these are the, as I had already spoken about three frequencies, x1, x2, x3. At this frequency we had noted down this data of vibration amplitude in velocity mode, that is mm per second, and by using the values of dependent variable, that is vibration amplitude, and the values of independent variable of the system, we have developed this, the regression equation. By putting this value in this matrices, we have formed three models, that is in horizontal and in vertical. So this Y is the amplitude, vibration amplitude. These are the pi terms. This is the indices. Now we have developed the equation. अभी इक्वेशन में कर क्या है? पाई 1 यानी हो गया मेरा तुम्हारा इनर्शिया रिलेटेड पैरामीटर, आपका सिस्टम है, इनर्शिया रिलेटेड पैरामीटर डाल दो, स्टिफनेस से डाल दो, लेंथ डाल दो, डायनामिक सिस्टम डाल दो, आपकी सिस्टम है। मेरा इक्वेशन बता देगा कि वाइब्रेशन एम्पलीट्यूड कितना है। इट्स अ प्रेडिक्टेबल। सर मेरा सिस्टम दूसरा है, आपकी इसमें स्पीड इतनी है, मेरी तो कम है, तो आप लोग अपने डाल दो, तो यू विल गेट a predictive model, and that's why it is known as generalized equation. कौन सा equation? Generalized. So now qualitative analysis we had done. I will skip that. Next. पहले दिखा सकते हैं qualitative. See, pi 1 is the mass moment of inertia. इसका index है -0.9. इलास्टिसिटी कैरेक्टरिस्टिक का -2.0, डायनामिक का -0.08, इक्विवेलेंट इसका 1. Indices of the pi. Negative indicates it is inversely proportional. Which proportional? Here, in this case, negatively, the 2.0 is having the maximum magnitude. Therefore, it is stated that the elasticity characteristic for generation of vibration amplitude is more dominant than. So we have to focus on that. If we want to mitigate the vibration, you have to control or optimize that part. Understand? Yes. The value of perfecting constant is 1. So 1 is the good model. सभी अपन ने 1 क्या करता है? It indicates that all possibilities to take the independent variable you have chosen there. There are certain analysis which is being implemented for quantitative analysis of the model, sensitivity, optimization, and reliability. Next one. Sensitivity means your pi term, how much it is sensitive. If I let us consider 10% increase किया तो इधर भी 10% होता है। ये कितना होता है? This checking is nothing but this sensitivity analysis. How much sensitive your pi term is. And optimization is what? At what value of the pi term you will get a mitigated value of vibration. हमारा क्या उद्देश्य है? वाइब्रेशन कम होना चाहिए, तो हमारा ऑब्जेक्टिव फंक्शन क्या होगा? जो डिपेंडेंट वेरिएबल है छोटा होना चाहिए. That's why optimization, from optimization we will get the optimized value of the pi terms. Next. So we have done that. This is the sensitivity analysis. Pi 1, pi 2, pi 3. You can see that pi 3 term is most sensitive than others. इसमें हमने क्या किया? हर पाई टर्म में 20% प्लस माइनस 10 सब में चेंज करके y की वैल्यू निकाला उसको. This is the decreasing order of sensitivity. Next, optimization. Next, these are the procedures. Next. This is the obtained the optimum values of the pi term at which the vibration amplitude is reached. Reliability of model, it is indicating the chance of failure and an indicator to show the performance of the model. जो हमारा आया है, ये हमने procedure निकाला है. Next, these are the reliabilities we obtained from our model. It is an approximate model. It's not the exact model. That's why it has a proportionality constant k, and it is a simulating the exponential model, right? So here these are the reliabilities of that model. Next one, these are the conclusion. An attempt is being made to understand the relationship between amount of misalignment and growth of amplitude and form the rigorous study. It is revealed that it falls under non-linear. So there is no relationship between amount of misalignment and amount of vibration amplitude. Next one. Next one. These are the references. मेरा एक ही कंक्लूजन था जो मैंने बताया कि there is no relationship between the amount of misalignment and amount of vibrations. Right. So vibration, I invite you to work on this concept. Very soon I will actually organize one workshop. I will be the speaker in that. I will explain right from the beginning how the vibration starts and how it culminates to the advanced vibrations. So if you would like to join that workshop, you can. It is a free of charge in PC for student and faculty members. Right? So you have my numbers and email ID. My number is with my nobody sir. You can take. And if anyone interested to join that workshop, you can. You are invited in that. And my last request, which I feel through the research. Everyone researching, not inventing. हम रिसर्च कर रहे हैं, रिसर्च. पेपर भी तभी पब्लिश होता है जब वहाँ रेफरेंसेस है. If you come out with a new concept, you have to validate. रिजेक्शंस आते हैं क्योंकि हम अभी रेफरेंस पे चल रहे हैं. क्या फायदा इतने पेपर पब्लिश होते? व्हाट इज द बेनिफिट? हमारा एक तो भी रिसर्च सोसाइटी को यूज आया. माय हम्बल रिक्वेस्ट, डू द रिसर्च फॉर द सेक ऑफ द बेनिफिट ऑफ द सोसाइटी देन रिसर्च. ओनली गेटिंग अ डिग्री इज नॉट मियरिंग रिसर्च. You have to do something for the society. आपका एक पेपर नहीं हुआ चलता मेरे, हजारों पेपर हो जाते लोगों को. Does not mean एक आपका काम, एक प्रोडक्ट जो आपके सोसाइटी में जाके आपका नाम बदले, आपके उससे किसी को हेल्प हो, वही रिसर्च है. Am I right? तो मेरी एक रिक्वेस्ट, रिसर्च यानी क्या है, इनोवेशंस यानी क्या है, कुछ तो भी अलग करने की चाह, कुछ तो भी सोसाइटी को देने की इच्छा. मुझे एक तो भी बताइए कि हमने प्रोडक्ट बनाया है क्या, बनाना चाहिए हमने प्राइवेट कॉलेज में. तो इट इज अवर ड्यूटी एज अ टीचर टू मेक अ रिसर्च फॉर द सोसाइटी. एम आई राइट? ये मेरी हम्बल रिक्वेस्ट. देखो मैं जो आदमी हूँ सबको मालूम है, आई एम वर्किंग फॉर द स्टूडेंट्स. एवरी टाइम आई एक्चुअली ऑर्गेनाइज वर्कशॉप फॉर द स्टूडेंट्स. The reason is that हमारे भविष्य है और हमारा दायित्व बनता है हमारे स्टूडेंट को अग्रसर करें, हमारे स्टूडेंट को नर्चर, और वो स्टूडेंट ऊपर जाते हैं तो मजा आता है. हमारे से 3 लोग कभी जलते नहीं. आपकी तरक्की से 3 लोग नहीं जलते, एक आपके माँ बाप और एक आपका टीचर. गर्व महसूस होता है. तो बस यही एक मेरी गुजारिश है, जो भी आप रिसर्च कर रहे हैं, जो पढ़ा रहे हैं, उसके साथ कुछ तो भी सोसाइटी को मिले, कुछ तो भी अलग करो. मुझे बहुत अच्छा. ठीक है. थैंक यू वेरी मच फॉर हैविंग पेशेंस टू लिसन माय लेक्चर.
Very good afternoon to all of you. लगे क्या?
Yes.
Actually, MEHTA sir and myself work of 5 years. हमारे साथ जयश्री भी थी, प्रियदर्शनी में. We was again a part of our team, and we work together. Actually, we have a lot of competition type of environment. और एक साखरे सर भी आएंगे अभी. ठीक है. साखरे सर, MEHTA सर, हम लोग there are sometimes of debate like, but अभी जैसे सर ने बताया कि there was a competition, but that is not for other purpose, that is for healthy competition. ठीक है. And that's the result that we have make a good relation. Something जो कोट का है कि that whatever the research that you are doing, that is not only for the sake of your degree, means सिर्फ बस PhD मिल गई कि उसको, that is not for promotion, हमने साथ में काम किया, बट टिल डेट और वन ऑफ एनी PhD स्टूडेंट हमारे भी अंडर में जो स्टूडेंट है सर के अंडर, साकेत सर के अंडर, if we face any problem we will get interact with each other nowadays. हमारे सर के साथ भी हमारा डिस्कशन होता है, ठीक है, सर के भी स्टूडेंट हमारे, तो इसलिए सर को भी पता है कि दैट आई वाज व्हाट इज माय PhD टॉपिक एंड व्हाट इज माय कंट्रीब्यूशन, that when you are doing the PhD on my PhD topic, I am it is a really honor for me कि on that topic I am going to complete the work of internship. NTP पुराड़ी थर्मल पावर स्टेशन, खापरखेड़ा पावर स्टेशन, भुसावल पावर स्टेशन, SK मित्रा कोल लैब नागपुर, देन पारस पावर स्टेशन, देन पुणे की क्लीन लेबोरेटरी नेरी, नागपुर का जो नेरी है, ठीक है, दैट आई हैव with on my this PhD research topic that I have completed the work of this young number of organization, and that's why I feel very proud when I get a chance to work with my mentor and my guru Dr. Lakesh sir, ठीक है, फिर that such kind of work, जैसे सर ने बताया कि पेपर नहीं भी हुआ तो चलता है, but when we solve the problem on our internship, जब हमने internship के problem मेरे गाइड के साथ में प्रॉब्लम ऑडिट फेस करने जाता था तभी, ठीक है, तो ऐसे सर ने जो बताया कि सर को भी पता है मेरे PhD के किस्से, हमको एक दूसरे के सब किस्से पता है, ठीक है, फिर एक्सपर्ट मेरा सेमिनार के टाइम हमारे एक्सपर्ट ने मुझे रोक दिया था, ठीक है, ऐसा वैसा, ठीक है, बट दैट इज द माय गाइड हैज ओनली टेकन द स्टैंड कि नहीं, मेरा ये जो PhD स्टूडेंट है इसके PhD वर्क के कारण माय गाइड हैज get a benefit of near about 1 crore rupees. मेरे PhD के वर्क के कारण मेरे गाइड को 1 करोड़ प्लस बिजनेस हुआ है, एंड जितने भी मैंने नाम लिए आज भी उसी ऑर्गेनाइजेशन में जब भी NABL का काम होता है मेरे गाइड, आई एम रियली थैंकफुल टू हिम, मेरे गाइड मुझे अभी भी कॉल करते हैं, आई एम टेकिंग द ट्रेनिंग टू द इंडस्ट्री, 2-3 दिन के वर्कशॉप में अभी भी कंटिन्यू वर्कशॉप ले लेता हूँ, दैट इज अ पेड वर्कशॉप, इसी में था तभी भी ले लेता था, सर को भी पता है कि that whenever you do the work, really do the work for the society where you will get the benefit, not only for the sake of your paper degree. नहीं मैंने PhD कर ली, मुझे 3 इंक्रीमेंट लग गए, प्रमोशन मिल गया, that is not the purpose, ठीक है, and there should be the healthy competition. जैसे सर ने बताया कि तीन लोगों को जलन नहीं होती है, एक माँ बाप और एक, मैं उनमें और एक ऐड करूँगा जो एकेडमिकली अच्छे दोस्त होते, ठीक है, उनको भी कभी ये नहीं लगता कि मुझे ये नहीं, मैं PhD बन गया कि मुझे ये नहीं आता है, आज भी मैं सर को फोन कर सकते, सर मुझे फोन करते हैं, अभी सर एक बताओ आपको एक PhD स्टूडेंट का अभी कल एक काम आया, तो वी आर डिस्कसिंग ऑन दैट वर्क इज कंप्लीट, ऐसा नहीं कि हमारा PhD हो गया तो हमारा वर्क स्टॉप हो गया, still we are helping the different students who are going to complete the work of the PhD, and PhD गाइड का एक रोल नहीं होता कि एक गाइड सिर्फ एक बच्चों को सफिशिएंट नहीं होता कि यू विल कंप्लीट द वर्क ऑफ दैट स्टूडेंट, दैट ही हैज टू टेक द हेल्प, जब वो गाइड भी रुक जाता है, अभी मुझे वाइब्रेशन का काम पड़ा तो मैं मेहता सर के हेल्प लूँगा, मैथमेटिकल मॉडलिंग का काम पड़ा तो दैट आई विल टेक, साकेत सर को जब भी काम पड़ता है ही विल टेक माय हेल्प, ठीक है, सो दैट इज द इंटरडिसिप्लिनरी एंड दैट इज द ग्रुप अप्रोच, देन वी विल गेट सक्सेस इन द सोसाइटी, एंड दैट इज द नीड ऑफ टाइम, बिकॉज नोबडी विल बी परफेक्ट इन दिस वर्ल्ड, और जो ऐसा बंदा होगा कि खुद को परफेक्ट समझता है, he cannot do anything, so आज भी मैं पढ़ रहा हूँ, आफ्टर कंप्लीशन ऑफ माय PhD आई एम डूइंग MBA, मैं अभी भी MBA कर रहा हूँ, ठीक है, MBA कंप्लीट करने के बाद मुझे MA इंग्लिश लिटरेचर करना है, ठीक है, so that we should get some knowledge and we should get something, so in life I am thought that I am thinking I should be the student, हमारे स्टूडेंट है तेजस पीजे, जिनसे भी मैं कुछ सीखता हूँ, ये हमारे बहुत होनहार स्टूडेंट है, ठीक है, सो फ्रॉम एवरीबडी दैट वी शुड लर्न समथिंग, हमारा जूनियर क्यों ना हो, ठीक है, सीनियर क्यों ना, एवरीबडी दैट वी शुड लर्न समथिंग, दैट इज द रियलिटी ऑफ आवर लाइफ। विद दिस आई एम वेरी मच थैंकफुल टू माय फ्रेंड्स डॉक्टर गिरीश मेहता for accepting my invitation and spending the time for this valuable session. Thank you.